The universe holds many secrets that span across the vastness of space and time, waiting to be discovered by curious minds. Some of these secrets are hidden in the far reaches of the cosmos, in the distant galaxies and nebulae that we can only glimpse through powerful telescopes. Others are hidden in plain sight, right here on our own planet, in the elements and materials that make up our everyday world. Deuterium is one of those secrets. It is a form of hydrogen, an element so common that it is found in every drop of water. As an isotope of hydrogen, deuterium has one proton and one neutron in its nucleus, making it twice as heavy as the more common hydrogen isotope. But this small difference gives deuterium the potential to revolutionize energy production in ways we're only beginning to understand. Imagine a future where the vast oceans, which cover more than 70% of our planet, become a boundless source of clean, sustainable energy. This is the promise of deuterium, a promise that could lead us to a new era of energy abundance and environmental harmony. Deuterium is a powerful fuel source for fusion, the same process that powers the sun and stars, providing them with their immense energy. Fusion is the process that powers the sun, where atomic nuclei merge to form a heavier nucleus, releasing vast amounts of energy in the process. It involves merging atomic nuclei to release tremendous energy, a process that, if harnessed on Earth, could provide us with a nearly limitless source of power. Deuterium, when fused, releases more energy than any other known reaction, making it a key to unlocking the potential of fusion energy. This energy could power our world for millennia, providing a stable and sustainable energy source that could transform our civilization. The quest to unlock this potential is a scientific adventure, one that involves exploring the very building blocks of matter and the fundamental forces of nature. It is a journey into the heart of matter itself, a journey that could lead us to a brighter, more sustainable future for all of humanity. To understand deuterium, we must journey into the heart of the atom. Atoms are the building blocks of all matter. They consist of a nucleus orbited by electrons. The nucleus contains protons and neutrons. Protons have a positive charge, while neutrons have no charge. Hydrogen, the simplest atom, usually has one proton and no neutrons. Deuterium, however, is different. It is an isotope of hydrogen. Isotopes are atoms of the same element with the same number of protons but different numbers of neutrons. Deuterium has one proton and one neutron. This extra neutron makes deuterium heavier than ordinary hydrogen. This difference in mass is key to deuterium's energy potential. The story of deuterium begins in the earliest moments of the universe. The Big Bang created a sea of elementary particles. As the universe cooled, protons and neutrons combined to form the first atoms. Most of these were hydrogen, the simplest atom, but a small fraction combined to form deuterium. This process, called Big Bang nucleosynthesis, created the initial abundance of deuterium in the universe. Today, deuterium is formed in stars. Inside these stellar furnaces, hydrogen atoms fuse to form helium. Deuterium is an intermediate step in this process. The fusion of deuterium releases energy that helps power the star. Deuterium may seem rare, but it is surprisingly abundant. It exists throughout the universe, a relic of the Big Bang and ongoing stellar processes. On Earth, deuterium is found primarily in water. Water molecules consist of two hydrogen atoms and one oxygen atom, H2O. However, a small percentage of these hydrogen atoms are actually deuterium. This heavy water is slightly denser than regular water. While the concentration of deuterium in water is low, the sheer volume of water on Earth makes it a vast potential energy source. Oceans, lakes and rivers all contain this valuable isotope. Section 5. Extracting deuterium, a technological challenge. Unlocking the energy potential of deuterium requires extracting it from its source, primarily water. Deuterium, also known as heavy hydrogen, is a stable isotope of hydrogen with a nucleus containing one proton and one neutron. This makes it twice as heavy as the more common hydrogen isotope, which has no neutrons. This extraction process presents a significant technological challenge. The rarity of deuterium in natural water, about 1 part in 6,400, means that large volumes of water must be processed to obtain useful quantities. The most common method is called the Girdler sulfide process. This method has been used for decades and is well understood, but it is also complex and requires careful handling of chemicals. This process exploits the slight differences in the physical properties of heavy water and regular water. Heavy water, or D2O, has a higher boiling point and density compared to H2O, which allows for separation techniques to be applied. It involves a series of chemical exchanges between water and hydrogen sulfide gas. These exchanges gradually increase the concentration of deuterium in the water. This process concentrates the deuterium in the water. The enriched water is then further processed to extract pure deuterium. Another method uses electrolysis, passing an electric current through water to separate hydrogen and oxygen. This method is simpler but less efficient compared to the Girdler sulfide process. Deuterium, being heavier, is separated more slowly. This slower separation rate requires precise control and monitoring to ensure the purity of the extracted deuterium. Both methods require significant energy input, making the process energy intensive. The energy costs are a major factor in the overall feasibility of deuterium extraction on a large scale. However, the potential payoff, a near limitless energy source, makes this challenge worthwhile. Advances in renewable energy and more efficient extraction technologies could make deuterium a key player in the future of sustainable energy. Section 6. The Philippines' bold vision, deuterium. Research and development. The Philippines, an archipelago nation facing energy challenges, has recognized the potential of deuterium. The government has announced plans to establish the Philippine Deuterium Research and Development Authority. This ambitious initiative aims to position the Philippines as a leader in deuterium research and development. The authority will focus on developing efficient and cost-effective methods for extracting deuterium. It will also explore applications of deuterium beyond energy production. These include medical isotopes for imaging and treatment, as well as industrial applications. This initiative is a testament to the Philippines' commitment to scientific innovation. It is a bold step towards a future powered by clean and sustainable energy. Section 7. Deuterium fusion powering the future. Deuterium is a key ingredient in fusion reactions. Fusion is the process that powers the Sun and other stars. It involves merging atomic nuclei to release tremendous energy. Deuterium, when fused with another deuterium nucleus or a tritium nucleus, releases more energy than any other known reaction. This energy can be harnessed to generate electricity. Fusion power plants promise a clean and nearly limitless energy source. Unlike fission, which powers current nuclear plants, fusion does not produce long-lived radioactive waste. It is also inherently safe, as a runaway reaction is impossible. Deuterium fusion holds the key to a future free from fossil fuel dependence. Section 8. Global implications, a new energy paradigm. The pursuit of deuterium fusion has far-reaching global implications. It has the potential to revolutionize the energy industry, transforming how we power our world. Imagine a world where energy scarcity is a distant memory, a world where countries are no longer reliant on fossil fuels. This is the promise of deuterium fusion. However, the development of fusion power is a complex and challenging endeavor. It requires international collaboration and significant investment. The rewards, however, are immense. Deuterium fusion could help mitigate climate change, reduce global conflict over energy resources, and usher in an era of global prosperity. Section 9. A Deuterium Future. Hope for a Sustainable World. In this chapter, we explore the transformative potential of deuterium, an isotope that could revolutionize our energy landscape. The journey towards a deuterium-powered future is just beginning. This journey is not just about scientific discovery, but also about the collective effort of humanity to create a sustainable world. It is a journey fueled by scientific curiosity, technological innovation, and a shared vision for a better world, teams of scientists and engineers are working tirelessly, driven by the dream of a cleaner, greener planet. Deuterium, once an obscure isotope, is now emerging as a beacon of hope. Its unique properties make it a promising candidate for sustainable energy solutions, offering a glimpse into a future where our energy needs are met without harming the environment. It represents a future where energy is abundant, clean, and accessible to all. Imagine a world where renewable energy sources like wind and solar are complemented by the power of deuterium, creating a harmonious and sustainable energy ecosystem. The challenges are significant, but the potential rewards are even greater. Overcoming these obstacles requires collaboration, innovation, and unwavering determination. The path is fraught with difficulties, but the vision of a deuterium-powered world keeps us moving forward. As we continue to unlock the secrets of deuterium, we move closer to realizing its full potential. Each breakthrough brings us one step nearer to a future where deuterium can provide clean, limitless energy. A future powered by deuterium is a future filled with promise. It is a vision of thriving cities, healthy communities, and a planet that can sustain future generations. It is a future we must strive to achieve for the sake of our planet and future generations. By investing in deuterium research and development today, we are paving the way for a brighter, more sustainable tomorrow. Let us embrace this journey with hope and determination, for the future of our world depends on it. If you believe in a sustainable future, don't forget to like, share, and subscribe to our channel. Join us in spreading the word about the potential of deuterium energy. Together, we can make a difference.